Okay, right. Welcome everyone to the third and final of these planning and development workshops for the CalMIP project. So today we're going to talk a little bit about the post-analysis again, because I think it's going to help us get a little bit more of a vision of what we see this CalMIP looking like and moving forwards. And then we're going to go over the draft protocol. There are a few questions on the document, and I think we decided that it'd be nice to be able to talk these through, and then we'll do feedback, decisions, and then the next steps. Before getting started though, I thought it would be a good idea to basically reiterate the guiding principles, just to help us kind of frame what we're trying to do. The idea is really to just see how well the in-house calibration methods that already exist around models can be used to reduce model data fit and the spread across models. So it's less about comparing different calibration methods themselves and more about seeing how by calibrating different models we can reduce the spread across different models. And we've wanted to keep this relatively simple and have it as a come as you are approach. And this is really to let most groups participate. We don't want people to have to develop whole new systems and learn new methods that they're not familiar with. It's really about what you have in-house and what you can use in this first phase of the project. And to also keep it simple, we're not going to be looking at future projections at this stage. And like I said, we're not going to ask people to do complicated calibration setups they're not used to working with. But we also know that people are going to have the capability of doing more. So all outputs are going to be on a public repository. And we also encourage people to also put additional data on there as well, if there's also more model outputs that you want to be sharing with the community. And the idea is at this first stage to be doing site optimizations, and then we're going to be following this by a global scale post-automation simulation as the principal analysis. So just a little bit of a summary and reminder of what's come out of the previous sessions. I think there's been a little bit of confusion about what fluxes we're going to be providing. We're only really going to be providing NE, which we might split into GPP and respiration, latent heat and sensible heat for this first phase. And maybe later phases we can re-explore which variables provided, but these will be the ones that we will be focusing on. And we are hoping to work with global scale grid and land surface models. So we're not looking at river catchments or anything that wouldn't be able to fit with these site-based simulations. And as you know, we sent out this survey last week, and the majority of the groups can run a global simulation. And so we are going to require this as part of the post-processing analysis, and we will be following a trendy protocol with trendy forcing data to do so. So like I said, we wanted to take a step back again and think a little bit about what kind of questions we want to be answering with this work. And so this is a slide from last week. And this is one of the ideas, could be to, by looking at the different models before calibration and after calibration, do we change the global mean annual NPP? Do we get more consistency across models after calibration? Do we reduce the spread across models after calibration? Or when we have like known biases, for example, in evapotranspiration, are we able to correct these biases by calibrating across all models? Is the data sufficient to give us that information? So these are some questions, but you might have other visions of what we can do with these kind of calibration and global runs afterwards. And I think it will be useful to talk about these a little bit because it's going to help us decide, for example, do we want to be looking at posterior parameters and uncertainties, or are we more interested just in the output uncertainty? Do we want ensemble runs? All of these kind of questions, but I think it will help if we actually phrase it more in what kind of scientific questions are we going to answer. So this is what we're going to do. We're going to have quite a short breakout session. And we're going to be talking about this